Hello everyone and welcome. This is a recording about the Python animation tutorial for those of you who are not able to make it with us live. So let's go ahead and get started. I'm going to share my screen. Also, you should have the slides I'm sharing and also the code available on our class Moodle page and also at the link of the resources that is provided in the slides here. So today we're going to talk about how to create this little Python game. The object of this game is there is a shooter, and this shooter, when you click this red trigger button, the trigger moves across the screen and it triggers this bullet to shoot across the screen, and then the object is to get that bullet to hit this blue ball, which will be moving around on the screen. So there's a number of different graphics one could make that are similar to this. We had the turtle races in class. One could also make the Pac-Man game or perhaps even a sports game board. This is a link to our materials on the Google Drive. This virtual Zoom workshop ran in 2020. We have some recorded videos from this as well. So we could make a number of different games based on this with the turtles, as I just mentioned. But today we will look at how to make that shooter game. So this is adapted from the code displayed at dannyweb.com. So let us consider how we would set this up. So this is just an overview of the code. We see we're going to do a series of steps, and what we're going to do is consider each of those in turn. As I mentioned, this code is available for you to download and use as a starter for your project. The key areas in the code we're going to look at is the setup of the game, how we can create the turtle objects, which represent that the red square for the shooter, the bullet, and the ball that we're trying to hit, how we can initialize the game, how the game loop would proceed, and finally, how the game termination would occur. So setting up for the game, the first thing we're going to do is we're going to do all of our imports. We're going to need turtle, random for a random number, and math in order to start this up. Notice we have a couple of different import styles, but basically this is just importing the parts that we're going to use from these modules. We also need to define a function called shooter clicked. This will take the X and Y variables as input. We need to define a variable called start, which is going to be a global variable. So when we talk about functions, we talk about how variables terminate when the function ends. By causing them to be global, this overrides that default feature and allows the variable to persist even after the function ends. So we're going to set start equal to true and return this. So this is what is, excuse me, going to cause the shooter, that red square, to move across the screen and trigger the bullet. Next thing we're going to do is set up the game space. So the game board is going to be 600 pixels by 500 pixels. Now what we're going to do is we're essentially going to set the origin in the middle of the game so that we can then use a coordinate system from negative 250 to positive 250 and positive 300 to negative 300. So notice that would put the origin right in the center, and that these basically add up to the setup coordinates, the size of the game. We can also apply a title to our game, and also I've chosen to make the background color light blue. Next, what we're going to do is create some turtle objects. Those turtle objects are going to be the actual players on the game. So when we've been doing turtles so far, we typically have just one turtle on the screen, but we could also create an example of a turtle, and we do that simply by this syntax right here. So here we're going to create the turtle to represent the ball that we're trying to hit. So here we have ball equals turtle in parentheses. Notice that the turtle begins with a capital T, which will make it an example of the turtle class. We'll talk more about object-oriented programming in the upcoming lecture. Here we are doing the dot notation to use the methods that are the attributes of turtles. And by putting the name of a turtle here, we're specifying which of the turtles is going to do that thing. So here the pen up causes the pen to go up so that it does not trace out its path. Here we're setting the shape to circle. The shape size will control the dimensions of the circle, so it can be perturbed to be an oval or cigar shape by changing these numbers here, but when they're all the same, it basically is a sphere. Here we're setting the color, and the bounce point is set to 20. What this means is that when this ball encounters the boundaries of the game, how far off the boundary do we want to allow it to go? So if the radius of the ball is 20, what we want to do is we want to make sure that when it hits that point, that it is not going to sink into the wall so that it looks more realistic. That means that the effective boundaries now are going to be 20 pixels inside of those 250 by 3, well, I guess we did minus 250 to positive 250. So you would come in an additional 20. So when the center point gets there, that is when it will bounce out. Next, we create a turtle that represents a shooter. That is the thing that you can click to get the bullet to move. So here we're going to do, again, a definition of a turtle. So here we created a turtle that has the name ball. Here we use a turtle that has the name shooter. Here we're hiding the turtle so we can't see it. Put the pen up. We're going to set the shape to the square. Again, these dimensions are going to allow you to change the way the shape appears. Here we're coloring the shape red, and here the go-to command is sending the center of this red square to these coordinates using the axis system that we set up above. Here we're going to create a turtle that represents the projectile. The projectile is equal to turtle, which creates the projectile. Here we're hiding it, and again we put the pen up so it doesn't trace its path. The shape of the projectile is the circle. Here, notice that we have set this to be smaller, 1, 1, 1, as opposed to 3, 3, 3. And we send the projectile to a particular position on the board. And we're going to do shooter.onClick to capture the shooter.click coordinates that are needed to execute that function that we looked at just a moment ago. To initialize the game, we'll need to do some more setup. That is the coordinates. So we're going to randomly select coordinates between the X and Y values that are available on the board, less their bounce point. So it will be the minimum plus the bounce point, which will say that the ball must be inside that boundary, plus the size of the ball so that the ball doesn't sink into the sides. And the same on the other end, and the same in the Y coordinates. Once the random numbers have been selected for X and Y, the ball will proceed to those coordinates. Then we're going to turn each of the turtles on. By having the turtles off, that means that they silently move to their location so that they're invisible, and then they appear in the location where they're at. So here we're turning them back on. Next, we're going to need to set up a step size. The step size, dx and dy, are the amount or the increment that the object will move during a step of the game. So you might think of a ball rolling at a certain rate, and over some delta t, it will traverse some amount of distance x. It will also traverse some amount of distance y. So we have the X and Y coordinates that give the amount that it's going to move. Here we're saying that in one step of the game, they will move by 10 pixels. We're also going to need the coordinates for the shooter, and so this is going to be used for that. We're going to set the end loop to false and start to false. This is again just showing a picture of the game in action. Here is our shooter going across, which means the projectile is going to shoot, and we're going to see if it will hit the blue ball. So while this is not end loop, right? So while this is true, we are going to move the ball. We are going to move the coordinates of the ball throughout the game. So here we have double X, which will represent the new value of X because this is being animated and moving across the field. The current value of X plus the dx, that delta X that we chose above. So normally what one would do is one would just have, say, like a pool ball rolling along, and you have some delta T, it will move some amount. So the new coordinate will be the old amount plus the amount that it moved, the delta, to give the new coordinates. That's basically what this is saying. However, if the new coordinate causes it to be impinged on the walls of the board, then what needs to happen is it needs to bounce. And so in order to do that, we're going to reflect the coordinates. So here we're reflecting the X, and here we're reflecting the Y, and these are on the, here we're reflecting the X's on, sorry, not X and Y, these are the Y's down here. These are going to handle the situation of hitting the left or the right boundary, the lower or the upper. Here we'll also do that, the same thing for the Y. This says the new value of X equals the current XX value, and here the value of Y will also be updated to the YY calculated under these conditions. Then the ball will be sent to the new coordinates. Here we are setting up where the shooter goes. So this is why we needed those extra coordinates, the minus BY and minus BDY. This will set up the shooter. So if the start equals true, then the shooter will start into action. And so here, if the BY is greater than the maximum Y, BY is going to be equal to negative 220, and we reset the start to false. So basically, by clicking on it, we'll be able to trigger it to become true, and the shooting will actually occur. So if the projectile distance of the ball is less than 40, then this means that the projectile distance to the ball is very small and that it has been hit. So then we would use the target affirmed and you win, and we would terminate the play of the game by setting end loop to true, which will cause this to become false. And then we would send the projectile back to 0.by. The by down here will terminate the execution and close the turtle. So the final thing we need to do is write the termination part of the code. So while not end loop, we had the code we were seeing above. So next we're going to look at if the projectile and the distance to the ball is less than 40, we're going to print target affirmed, you win, so the player knows that the game has been won. Here we're setting the end loop to true, and finally start is being set to false to reset the game. Here are some challenges for you to look at. How could the code be modified to change the shapes and colors being displayed? How could the trajectories and the projectile and the ball be traced? Experiment with the bounce parameter. How does it changing it affect the game? And finally, can more than one blue ball be created? I challenge you to take a look at those questions and see if you can answer them and or make the modifications that they request so that you can test yourself to see your mastery of the skills that were presented here. The answers are available for you to consider. Also here, I have the code appendices right in the slides. I have pasted the Python script file here so that you can copy and paste it to run, and also the solution to the questions that I have asked you to take a look at. As mentioned before, also these resources are available on our Moodle page. So if you're in my class, you'll be able to access it there. And if not, it's also on our Google Drive. If you found this helpful, especially if you are taking my coding class and are interested in working with Python animated graphics. Thanks so much. Enjoy.